Right now, on the far side of the planet, a slab of ice bigger than the country of Ireland is starting to come apart, and the scientists who have spent their entire careers watching it happen say they have never seen it move this fast. Stay with me for the next few minutes because I'm going to walk you through exactly what just changed, why researchers are suddenly using words like imminent instead of eventually, and what it actually means for the water outside your own front door. And if you want more science stories broken down in plain language with no exaggeration and no doom for the sake of doom, go ahead and subscribe to the Soccer Clock before we get into it. Let's start with the glacier itself, because the new warning only makes sense once you understand what is sitting underneath it. Thwaites Glacier sits in West Antarctica, and scientists nicknamed it the Doomsday Glacier years ago for a simple reason. It is one of the widest glaciers on Earth, roughly the size of Great Britain, and it acts like a cork holding back a much bigger reservoir of ice behind it. For years, the story around Thwaites has been one of slow, steady, worrying decline. But in the middle of 2026, that story shifted. Researchers coordinating the international collaboration studying this glacier say the last natural break in front of it, a floating slab of ice called the Thwaites Eastern Ice Shelf, is no longer just weakening. It is now expected to break apart within this year. That sentence is worth sitting with for a second because scientists rarely talk this way. Glaciology is a field built on caution, on decades-long timelines, on phrases like could occur sometime in the coming century. So, when a marine geophysicist who has coordinated the UK side of this research says plainly that the ice shelf is poised to disintegrate and that it is definitely going to happen, that is not casual language. That is a research community watching a structure they have tracked for years finally reach its breaking point in real time. To understand why this matters, you have to understand what that ice shelf actually does. Picture the main glacier as an enormous frozen river grounded on rock that dips below sea level trying to slide toward the ocean under its own weight. In front of it sits a floating shelf of ice, still attached, still pressing back against the glacier, the way a doorstop wedges against a door trying to swing open. That shelf does not stop the glacier, it slows it down. And it is only able to do that because one section of it catches against a ridge rising up from the seafloor, almost like a fingernail catching the edge of a table. Pull that anchor loose, and the doorstop stops doing its job. Here's what changed this year. Satellite monitoring shows that the western side of the shelf, right where it grips that undersea ridge, has been moving roughly twice as fast as it was just 8 months earlier. Deep fractures are spreading across the surface and the underside of the ice, in places researchers had never seen cracked before. One glaciologist who has been tracking this specific patch of ice since before the pandemic said that when she compared her older satellite images to the ones coming in now, she barely recognized the shelf. Huge gashes had opened where there used to be smooth, unbroken ice. So, how do we know this isn't just one scientist's gut feeling? This is where it gets interesting, because the case being made right now is not built on a single photograph or a single alarming quote. It is built on years of measurement layered on top of each other from completely different angles. Researchers have combined satellite radar, GPS instruments physically drilled into the ice, and years of velocity data tracking exactly how fast different parts of the shelf are sliding. All of it points the same direction. The fracturing is not slowing down or stabilizing, it is accelerating, and it is accelerating specifically at the one point holding the whole structure in place. Now, if you already know a bit about glaciers, you might be waiting for an important clarification. So, let me give it to you directly, because getting this part right actually matters. The ice shelf itself is floating. It is already sitting in the ocean, already displacing its own weight in water, the same way ice cubes floating in a full glass do not raise the water level when they melt. So, if this shelf shatters completely tomorrow, sea level will not visibly rise the next morning because of that event on its own. Any honest version of the story has to say that clearly, because skipping it is exactly how people either panic about the wrong thing or dismiss the whole warning as exaggerated. But here is the part that makes this genuinely serious. And it is the reason researchers are not shrugging this off just because the shelf itself won't move the tide gauges. Because the floating shelf was never the actual danger, it was always just the trigger. The real danger is what happens to the glacier once that trigger is pulled. Right now, while the shelf still presses back against it, the main body of Thwaites creeps toward the ocean at a certain pace. Remove that resistance, and glaciologists expect that pace to pick up. Not overnight, not by next month, but over the years and decades that follow. In a process that becomes very difficult to slow down once it has genuinely started. And this is where the story turns from a regional Antarctic curiosity into something that touches coastlines on the opposite side of the planet. Thwaites does not just hold back its own ice. It functions as a kind of keystone for a much wider section of West Antarctica, bracing the neighboring glaciers around it, including some of the fastest changing ice on the continent in a region scientists call the Amundsen Sea sector. Pull a keystone out from under an arch, and you do not just lose one stone. The whole arch can start to give way. If Thwaites destabilizes fully, researchers worry it could help unlock a much larger portion of the West Antarctic ice sheet, allowing far more ice than just this one glacier to start flowing toward the sea, faster than it does today. Let's talk about the actual numbers because this is where the warning stops being abstract. Thwaites Glacier on its own holds enough ice to raise global sea levels by roughly 2 feet if it were to melt completely. That alone would be enough to redraw flood maps in coastal cities everywhere, but because of its role as a structural pillar for the wider ice sheet behind it, the full collapse scenario that scientists model out involves a far bigger number, close to 10 feet of additional sea level rise worldwide. If a much larger stretch of West Antarctica eventually follows Thwaites' lead, that is not a number confined to Antarctica. That is New York, Miami, London, Shanghai, and Tokyo, along with low-lying nations like Bangladesh, where tens of millions of people already live within a few feet of the current high tide line. And here's the detail that has genuinely rattled some of the researchers working on this most closely. A study published earlier this year ran 2 separate, independently built computer models of how Thwaites behaves. Each one calibrated against real satellite observations collected over the past 2 decades, then projected forward to the year 2067. Depending on which real-world data set the models were trained against, they produced annual ice loss estimates in the range of 180 to 200 billion tons of ice per year by the 2060s. To put that in perspective, that is roughly the amount of ice currently being lost by the entire Antarctic ice sheet combined, coming from just this one glacier alone. The researchers found something that should genuinely unsettle anyone who assumes scientific models are always overblown. The models that most accurately matched how Thwaites has actually behaved over the past 20 years were the same models producing the largest, most alarming projections for the future. Usually, scientists hope the scariest possible outcome comes from the least reliable tool. Here, the opposite happened. The more accurate the model, the worse the forecast got. So, why is this happening now, and why does it keep tracing back to warm water rather than warm air? This is the part of the mechanism that a lot of people miss because it is happening somewhere no human eye will ever directly see it. Antarctica's ocean is not the same temperature from top to bottom. Sitting beneath the cold surface layer we normally picture as a band of warmer, saltier water, and because Thwaites and the basin it sits in dip below sea level as you move inland, that warm water is able to travel much farther under the ice than most people would assume possible. It pushes along the seafloor right up against the exact spot where the glacier grips onto the rock beneath it, and slowly melts that connection from underneath. The attack here is not coming from the surface, it is coming from below at the one place the ice can least afford to lose its grip. One research team studying the wider ocean system around Antarctica published findings this year showing that the waters surrounding the continent have undergone a genuine structural shift, with heat that used to stay trapped deep below the surface now rising upward where it is far more capable of reaching and undermining sea ice and glacier fronts. This matters because it means the mechanism driving Thwaites' retreat is not some isolated local fluke. It is connected to a much larger pattern playing out across the entire Southern Ocean, and the world's oceans in general have been absorbing somewhere around 90% of the extra heat trapped by greenhouse gases. All of that heat has to go somewhere, and some of it is quietly finding its way to the underside of one of the most consequential glaciers on the planet. There is another piece of this year's research that deserves attention because it changes how scientists think about when this whole process actually started. Using an underwater robot capable of swimming beneath the ice itself, a joint team of American and British researchers has been sending instruments directly into the cavity where the glacier meets the ocean, measuring water temperature and current speed in a place no ship or satellite can reach. What they found is that seawater is pushing more than 6 miles beneath the glacier's underside, far further inland than earlier models assumed possible. And when they combine the data with historical ice cores and older satellite records, they trace the beginning of Thwaites' retreat back further than almost anyone expected. To sometime in the 1940s, likely triggered by a powerful El Niño event that pushed unusually warm water against the Antarctic coastline at exactly the wrong moment. In other words, the retreat we are watching accelerate today did not start last decade. It started roughly 80 years ago, and it has simply been gathering speed ever since, largely out of sight, until the last few years finally pushed it into a phase that satellites and researchers on the ground could no longer ignore. That detail matters because it undercuts one of the more common objections people raise when a story like this comes up. The idea that this is simply natural variability, that ice sheets have expanded and retreated before across the planet's history, so none of this is unusual. It is true that Antarctica has gained and lost ice across long stretches of geological time. But a retreat that began with a specific climate event in the 1940s has continued essentially without pause for 80 years and is now measurably accelerating in step with a warming global ocean does not look like the slow, directionless wobble of a natural cycle. It looks like a process that got a nudge from a single event generations ago and has been pushed further along ever since by the broader warming trend layered on top of it. One glaciologist involved in the underwater survey work put it plainly: the team's findings show the glacier is set to retreat further and faster than earlier work suggested. Coming from a scientist whose entire job is measuring exactly how fast the system is moving, that is not a throwaway line. It is a direct update to how quickly researchers now think this story is unfolding, built on physical measurements taken from inside the very cavity where the melting is happening, rather than estimated from a distance. It is also worth being fair about where genuine scientific disagreement still exists, because good science means being honest about uncertainty rather than repeating only the scariest version of events. Not every researcher agrees on exactly how much support the ice shelf still provides to the glacier in its current, already weakened state. Some earlier work argued that whatever buttressing effect remains has shrunk down to smaller pockets along the shelf's edges, rather than being spread evenly across the whole structure, meaning its final breakup might not immediately kick the glacier into a dramatically faster gear the very next day. Other scientists have pushed back on the idea that Thwaites will collapse in a sudden domino-like cascade, arguing the physics involved make a runaway ice cliff scenario less likely than some of the more dramatic early headlines suggested. These are legitimate, ongoing scientific debates, and they matter. But almost every researcher working on this glacier agrees on the larger picture. The shelf's disappearance removes one of the last physical barriers in the system, and the surrounding evidence, from ocean temperature data to 2 decades of fracture monitoring, points firmly in the same direction of a glacier that is speeding up rather than slowing down. It helps to see this acceleration measured against its own history. Thwaites has been losing ice at a faster and faster pace since at least the 1980s, shedding hundreds of billions of tons of ice and pulling its grounding line back by roughly 12 miles since the early 1990s alone. That is not a glacier holding steady with that year. That is a multi-decade trend of retreat that keeps compounding on itself, and it is the reason researchers describe removing the eastern ice shelf as something closer to pulling a goalie in the final minutes of a hockey game. The goalie was never going to stop every shot forever, but as long as they were standing in the net, the other team had to work for every single goal. Take the goalie off the ice entirely, and suddenly the net is wide open, and whatever was already heading toward it gets there a lot faster. That is essentially the position West Antarctica is in right now. The ice shelf in front of Thwaites has been the last goalie, absorbing stress, cracking under pressure, buying time even as its own condition deteriorated. Once it is gone, nothing else stands directly in front of the glacier to slow its approach to the sea. The rest of the system, the deep basin underneath the ice, the warm water finding its way inland, the neighboring glaciers waiting on Thwaites to move first, all of that stays exactly the same. What changes is that the one structure standing between all of that potential energy and the open ocean finally steps out of the way. Let me be completely clear about what this new warning does and does not mean, because the honest version of the story is unsettling enough without adding anything extra to it. This is not a story about coastlines disappearing next month. The full collapse of Thwaites, if it eventually unfolds the way the more pessimistic models suggest, will play out over decades to centuries, because a body of ice this large carries an enormous amount of physical momentum and simply cannot empty itself into the ocean quickly. If someone tells you major cities will be underwater within a year because of this glacier, they are selling you a cartoon version of real science. And that kind of overreach only makes it easier for people to dismiss the genuine, well-documented risk entirely. What actually appears to be imminent, and what makes this year's warning different from previous ones, is specifically the loss of that floating ice shelf, the last natural break sitting in front of the glacier. Researchers now expect that to happen within this year, possibly within months. And what follows after that, the gradual speeding up of the much larger glacier behind it, is the part that unfolds over a much longer timeline, but is also the part that becomes very difficult to reverse once it has truly begun. It is also worth addressing the 2 kinds of misinformation that tend to show up whenever a story like this gets attention. The first is the idea that scientists are exaggerating for funding or attention. They are not. This research is published openly in peer-reviewed journals built on public satellite data and instruments physically placed in the ice and cross-checked by multiple independent teams using different methods that keep arriving at the same broad conclusion. The second is the idea that something artificial or deliberate is causing this melting. It is not. The heat responsible for all of this comes from oceans absorbing a staggering share of the extra energy trapped by greenhouse gases across more than 70% of the planet's surface, a force on a scale that dwarfs anything any machine could realistically direct at a single glacier. The real explanation here is simply widespread ocean warming, playing out exactly where physics predicts it would do the most damage, at the base of ice sitting in a basin that dips below sea level. So, what should you actually be watching for from here? Keep an eye out for the specific moment researchers confirm that the Thwaites eastern ice shelf has fully separated from the glacier behind it. Scientists monitoring the site say they are now checking satellite imagery on an almost daily basis because they genuinely believe that moment could arrive at any time. When it does happen, it will not raise the tide by a single visible inch that particular day, but it will mark the moment the last natural break came off one of the most closely watched, most consequential glaciers on the planet, and the beginning of a much longer chapter that coastal cities everywhere will eventually have to reckon with. Global sea levels have already been rising faster than they used to, roughly doubling in pace compared to the middle of the last century. And the mechanism behind that acceleration keeps tracing back to the same combination of factors. Warming oceans expanding as they heat up, and land ice, especially in places like West Antarctica, melting and sliding into the sea faster than it used to. Thwaites is not the only glacier contributing to that trend, but it is one of the largest, one of the most closely studied, and now, according to the researchers who watch it every single day, one of the most immediately unstable. Antarctica can feel impossibly distant from wherever you happen to be watching this video right now, but the ocean connecting that continent to your own coastline is not distant at all, and that is exactly why a crack spreading through a slab of ice at the bottom of the world deserves your attention today, not in 50 years, and not only once the headlines finally catch up to what researchers have already been quietly documenting for months. Every one of the pieces we have walked through today, the doubling of fracture movement over the past several months, the underwater robot readings from deep inside the glacier's cavity, the two independently built models converging on the same alarming number, and decades of retreat that trace back further than most people realized, all point toward the same simple conclusion. The break is coming off, nobody knows the exact day it will happen, and nobody is claiming the ocean will rise tomorrow because of it, but the researchers who study this glacier for a living are no longer treating its collapse as a distant hypothetical. They are treating it as something they need to watch every single day because it could genuinely begin at any moment. If this kind of clear, honest breakdown of the biggest science stories happening on our planet is something you want to keep seeing, subscribe to the Soccer Clock and turn on notifications, because there is a lot more unfolding out there that deserves the same careful, no-exaggeration treatment, and I would genuinely rather you hear it here first than get a distorted version of it somewhere else.